Yet again, have you ever checked on whether we're truly alone in the universe? Then again, have you accepted there's something else to our existence other than anything we see or envision? What is happening? Think about how conceivable it is that the James Webb Telescope finally shows that we live inside a black hole. Join us as we sort out more about this world, spreading the word that will make you question all that you believed you had some insight into as for the universe. So, what exactly are black holes? They're like something out of a thriller. Sure, you might have seen them in sci-fi films, but it's considerably more disturbing that they're not just an imaginary idea. According to well-educated experts, black holes in space are truly colossal amounts of matter pressed into an unfathomably minute district. Imagine a star a couple of times more massive than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Scientists have been hypnotized by black holes for a long time. Initially, they focus on objects in space so huge and dense that they could trap light. The most striking ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a gigantic star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. It isn't easy to identify black holes, as they emit no light. However, scientists have found ways to interpret their presence by seeing their effects on neighboring matter. For instance, if a black hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also significantly affect their surroundings. They can devour neighboring stars, produce intense light emissions, and even influence the formation of new stars in some regions while suppressing it in others. So, how exactly do black holes form? Picture this. Stars, once brilliant and shining, meet their fiery end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes form from gigantic stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something many refer to as neutron stars, which are incredibly dense, but not dense enough to trap light. If a star is several times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. As these massive stars collapse, something amazing happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the last defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours. Sometimes, when two smaller black holes collide, they merge to form a much larger and even more disturbing black hole. If a black hole interacts with a neutron star, it creates a complex nightmare that defies understanding. Scientists have been grappling with the size of these cosmic oddities for quite some time. Black holes come in two sizes, large and small. However, there's a bit of a misconception about them. Small is relative when it comes to black holes. Incredibly large black holes, remnants of massive stars, can be as much as 10 million times the mass of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's countless black holes that could swallow anything in their way. But wait, there's more. Extremely large black holes exist at the extreme end of the spectrum. They are millions, if not billions, of times greater than the Sun. These reside at the centers of large galaxies, including our own Milky Way. They seem like enormous dead spaces, pulling everything toward them. The renowned physicist Stephen Hawking discussed black holes throughout his life. His theories were well established, but some of his ideas proved difficult to confirm due to a lack of advanced technology. But now, there's hope on the horizon, not too far off. A single revolutionary instrument is changing all that. It's known as the James Webb Space Telescope, JWST, and it's here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a showcase of human ingenuity. Sure, we've launched other space telescopes before, and they've done their job competently, but this extraordinary machine is on a level that's truly remarkable. The JWST makes the Hubble, which has served us for so long, seem like a basic instrument. The retail cost of this vast marvel is a staggering $1 billion. Yes, you heard that right, an eye-watering number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this wonder to life, along with massive contributions from more than 300 universities. However, we shouldn't forget the risks that come with such a grand endeavor. I understand this isn't an undertaking for the faint-hearted. The JWST is venturing into an unknown world, pushing the limits of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made several key accomplishments. It traveled more than 1 million miles to reach its orbit around the Sun, where it will dwell indefinitely. During its journey, the telescope successfully deployed its enormous 5-layer sun shield and massive primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after adjustments and modifications, the telescope is almost ready for full operation. One of the most exciting aspects of the James Webb Space Telescope's mission was when NASA announced it had captured its first significant images of starlight. The first image taken by the telescope was of a star called HD 8446, revealing a series of 18 dispersed bright spots from the star's light gathered by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446, where 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory adjusts the individual segments of the primary mirror, it will begin the process of stacking images on top of each other to create one clear view. Thanks to its advanced technology, the JWST will help scientists study the early stages of the universe following the Big Bang. It will focus on what happened after the first stars formed in a period known as the Epoch of Reionization. This refers to when neutral hydrogen was reionized, given an electric charge by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are incredibly difficult to detect because of how they interact with their host stars. The JWST will now closely study these planets, allowing researchers to examine their atmospheres and investigate the conditions necessary for life. Beyond studying planet formation, scientists focus on these worlds to understand how matter is organized on a large scale. This, in turn, helps us understand how the universe has evolved, forming the galaxies we see today, billions of years later. One of the JWST's goals is to look back at the earliest galaxies to better understand how they developed. Scientists are also trying to determine how we got the range of galaxies we see today, as well as the ongoing processes that lead to the formation and merging of galaxies. So, are we alone in the universe? Eventually, the James Webb Space Telescope will help us answer this most fundamental question. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt, and guess what it has found? Compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around massive black holes in 3 active galaxies. These carbon-based molecules, with ring-like structures, seem to be the goths of the universe. They're found everywhere, from distant galaxies to comets in our own solar system. Now, they're not just interesting because they could form the building blocks of life, but also because they help scientists track star evolution. When intense radiation hits these PAHs, they become excited and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument. This is often a sign that there are some energetic, hot stars nearby. But wait for the twist. Astrophysicist Ismail Garcia Bernard from Oxford University decided to examine 3 fascinating galaxies, NGC 65, O2, NGC 731, and the Stephens Quintet, as well as NGC 749. These galaxies are millions of light-years away in the depths of space. What Garcia Bernard found will creep you out. In those central regions where the black holes reign, he saw a flood of PAHs. Sounds intriguing, right? Well, here's where it gets chilling. The radiation near these gigantic black holes changed the structure of the PAHs, turning them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into nothingness, being swallowed by the very darkness. However, the larger PAHs survived, finding shelter inside thin, dense gas clouds. It's as if they found their own protective cover against the wrath of the black hole's pull. Now, you might wonder why this dark wind matters. Well, for astronomers who rely on PAHs to track star development, it's crucial. Star-forming regions are often completely flooded with PAHs, which helps us understand how stars evolve. This discovery could revolutionize our understanding of how these compounds interact in extreme environments, particularly around black holes. The JWST's ability to detect these subtle infrared signals could help researchers decode the intricate processes occurring at the hearts of galaxies, where black holes dominate. By observing how PAHs behave near these cosmic giants, we might learn more about the chemical makeup of distant star-forming regions and even the early stages of planetary systems. As the JWST continues its mission, its findings will likely push the boundaries of astronomy and physics. It has the potential to answer some of the most profound questions about the universe, questions that have puzzled scientists for centuries. Could there be life beyond Earth? What are the true nature and origins of black holes? Are we truly alone, or are there other civilizations in the vast expanse of space? These questions, once thought to be out of reach, may now be within our grasp, thanks to the JWST's unprecedented capabilities. From exploring the formation of the first galaxies to probing the atmospheres of exoplanets, the telescope is paving the way for new discoveries that could change our perception of the cosmos. Each new image and dataset sent back from the JWST brings us one step closer to understanding the universe and our place within it. In the coming years, the telescope will continue to provide groundbreaking insights. Its findings will likely reshape our understanding of space, time, and the fundamental laws that govern our universe. As we stand on the threshold of this new era in space exploration, the potential for discovery is limitless. The JWST represents the next leap forward in our quest for knowledge, and its mission is just beginning. Whether it's unraveling the mysteries of black holes, studying the birth of stars, or searching for signs of life beyond Earth, the James Webb Space Telescope is ready to help answer the most pressing questions humanity has ever asked. With each passing day, the universe reveals more of its secrets that could ultimately reshape our understanding of everything we thought we knew.